All right, one of the last sections that we're going to cover, or really the last section that we're going to get to, is a section about chords, and we skipped over it. It's section 3 in chapter 10. So we're just going to look at a couple of theorems and how they apply quickly. Okay, so theorem 10.6, the congruent corresponding chords theorem. Okay, this is true. This is a theorem that's true in the same circle or if there are congruent circles. Okay, that if you have two minor arcs, they're congruent, then their corresponding chords are congruent, and that works in the opposite way as well. Okay, so if you know the two minor arcs are congruent, then you know the chords are congruent, okay, and vice versa. That's what if and only if means. Okay, now this is kind of an interesting one. So if you have a diameter that's perpendicular to a chord, then the diameter bisects the chord and its arc. Okay, so here we see we have our diameter, okay, and our chord. And so with this kind of interesting theorem, and if we were in school and had more time, we would certainly be proving these things, okay, and really looking at why this is true. And, okay, but for our purposes, we're just going to at least understand that this happens. So the arc gets bisected as well as the chord gets bisected. Okay, and the converse of that statement is true. So if you know the chord is bisected, then you know that the diameter is perpendicular to that chord. All right, so here we're going to pause for a moment and think about what the segment KH measures. Okay, and if you said 28, you are correct. Okay, this is because the chord would be bisected, okay, which means that both segments are 14, so 28 is correct. Okay, how about the measure of major arc HLK? Let's think about that. Okay, so because the two arcs are congruent, okay, we can set those equations equal to each other. We get x is 45, simple algebraic problem, right? And then we can solve and put 45 in for x. And in both cases, we get that the arc is 82. So the major arc HLK, okay, so if this arc is 82, right, these arcs are 82. We have to be careful, remember, and to answer the question that we're asked. So if you said 196, you are absolutely right. Okay, the measure is 196 degrees. All right, in a circle, we have two congruent, in this diagram, rather, we have two congruent circles. Okay, they're congruent because their radii are the same measure. Okay, and we are told that their chords are also congruent, and that we know the measure of one of the chords. Let's see. So we know the measure of arc JK. Okay, and we're asked to find the measure of FG. Okay, and if you said that FG was 120 degrees, you are absolutely correct. Okay, moving on. So this is kind of an interesting word, equidistant. Okay, it just means equal distance. Okay, the same distance. So if we have a circle, either the same circle or congruent circle, so our picture has the same circle, two chords are congruent if and only if. Okay, in future math classes, you'll see that abbreviated by IFF, if and only if. Okay, they're equidistant from the center. So keeping in mind, thinking about what distance is. If I go from the center, okay, to a point on a chord, I can go a lot of different ways, right? It can be here or here, but the shortest path from the center to the chord is the path that's perpendicular, or the segment that's perpendicular. Okay, and so that's what I mean about distance. I always look for the shortest path, the one that's perpendicular to the opposite side. And so if the two chords are congruent, those distances are congruent, and the reverse is true. Okay, if we know that that those distances FE and EG are congruent, then it must be true that the chords are congruent. So here, let's take a minute and study this example, and we'll do this one together, and then we'll get on to a little Kahoot to practice. All right, so we're told that chord QR and ST are all 16 here. Okay, so they're equal to each other, and they represent the length 16. Okay, we can see that that segment CU, the distance from the center to the chord, is 2x, and CV is 5x minus 9, and we're asked to find the radius of circle C. All right, so let's start here and thinking about the fact that we have the length, an algebraic expression for the length of CV and CU, and knowing that they are the distances from the center to chords that are equal length. We can figure out what x is, so go ahead and do that now. Okay, and so now once we have x, and if you got 3, you're absolutely right. Okay, we can figure out that CU is 6. Okay, what I always remind people is don't forget to go ahead and put the 3 in here, and just, it's a way of double checking. Make sure that you get 6 from this expression as well. Otherwise, you know you have something that's wrong. All right, then you say to yourself, well, where's there a radius? A set from the center to a point on the circle. Well, let's see. Okay, I can do a lot of radii I can draw, but if I were to draw this one in particular or something like it, okay, I have a right triangle where I know one of the legs is 6. Okay, if I knew this leg, I would be ready to go. And do I know that leg? I absolutely do, right? I know the chord is 16, and a previous theorem told us that that chord that was diameter perpendicular to the chord, the diameter would be bisecting that chord. So that's 8. Okay, now we have A and B are 6 and 8, and we can figure out the length of the hypotenuse. Okay, so go ahead and do that. If you remembered that you have a 6, 8, 10 triangle, which is just a triangle that's similar to our basic Pythagorean triple, 3, 4, 5. 6, 8, 10, a scale factor of 2, or doubling all the sides, tells us that the radius of circle C is 10. If you don't remember that or recognize that, you can always use the Pythagorean theorem. Let's get on with our Kahoot.